Hello, Leiden geometry students. In this assignment, we are going to talk about congruence. First off, what is congruent? Well, congruent is this little symbol. Now, you know parts of this symbol. Let's talk a little bit about it. First off, in geometry and in math in general, the equal sign means things are the same size. But this little part, the squiggly line on top, is a symbol in geometry for similar, meaning things are the same shape. To be congruent, two things have to be both the same size and the same shape. If you wonder what the distinction is, well, you could have a square and a triangle that have the same area. That might mean they're the same size, but they're not the same shape. To be congruent, you have to be both the same size and the same shape. For example, here's a triangle. I'm going to create a congruent triangle. Here's a matching triangle. These two triangles have the same size and the same shape. When I made this one over here on the right, I didn't change its size or its shape. I just performed a translation. These two triangles are congruent, both the same size and the same shape. If instead we performed some of the other transformations we did, if we do a reflection, here I create a new triangle. Now I flipped it over, but it's still the same size and the same shape. These two triangles are still congruent. It's still the same size and same shape. The same thing happened for rotations. If we perform a rotation on the first triangle, we create a new one and it looks all turned around and whatnot, but it is still the same size and same shape. These triangles are congruent. Next, we're going to talk about tick marks. Tick marks are all these little marks you see in the shapes, and our pictures are going to get a little bit more complicated, and these tick marks will save us a lot of time. Rather than write out that this part of one triangle is the same as this part in another triangle, we just put these little marks in. For example, these little marks right here that match in the two triangles are telling you that this side, side AB, and this side, side QM, are congruent to each other. Those two are the same. Why do we use those little marks? Because it's a lot easier than writing out the sentence, side AB is congruent to side QM. So we just use those little marks to represent that. For sides, our segments or lengths, we put in these little marks, straight lines through it, and they come in pairs. The single mark matches the single mark, double mark matches the double, and the triple mark matches the triple. We have another similar marking for angles. Here we draw in what are called arcs. That means part of a circle. And the number of arcs in this angle match the number of arcs in this angle, indicating that angle A and angle M are congruent to one another. These two triangles are congruent to one another. That means that every part in this triangle on the left has a matching part in the triangle on the right that's the same. And not only is it the same, but it's also in the same place. For example, the marks we just looked at, this side and this side. Side AB is congruent to side QM. They're the same, but not only are they the same, but they're in the same spot. Now, the triangle's been turned around, and I think it's been rotated and reflected. So when we can't say in the same spot, like they're on the left or the right, but they're in the same spot within the triangle. See, in the triangle on the left, the indicated side is between the angle with three arcs in it, and the angle with two arcs. Over here, that same side that congruent side is between the angle with three arcs and the angle with two arcs. Here, this pair of sides with two marks in it are congruent to each other. And in the triangle on the left, it's between the angle with two marks and the angle with one. In the triangle on the right, it's between the angle with two marks and the angle with one. They're in the same place within the triangle. And the same with all of them. This angle here with two arcs in it matches this one. And it's between the side with one mark and the side with two marks, And over here, between the side with one mark and the side with two marks, even though it's been reflected and rotated. And that's the same for all the different sets of matching parts. Now, first off, we're going to need a new word to describe this. Parts in the same place is clumsy, and by the same place, we mean the same place within the triangle. So instead of using this phrase, in the same place, we're going to use this word, corresponding. That means in the same place within the shape. Okay. So when our triangles are the same size and same shape, we're going to indicate that by writing out a statement that says it, what's called a congruent statement. When we write a congruent statement, we're just going to say this triangle on the left is congruent to the triangle on the right. And the way we do it is we use that congruent symbol and we name our two triangles. But there's a couple of catches here when we name the triangles. See this triangle on the left? It has a bunch of different names. I could call it triangle ABC or CBA or BAC or CAB or CBA or all, it's got like 6 different names. So even though all 6 names are okay, the best answer is to take the first triangle and name it alphabetically, or as close to alphabetically as you can. So we're going to call this first triangle, triangle ABC. For the second triangle, what it's going to be congruent to, I'm going to start naming it the same way. And don't forget, we got this little triangle symbol out front. I'm going to start with that, so I don't have to write out the word triangle. But I don't put the letters, just any letter. I got to put them so that they match each other. For example, in this first name, I started with the angle A. In the second triangle, I want to start with the angle that matches A so that they are corresponding angles, so they're in the same spot. So angle A is this angle over here with 3 marks in it. Its matching angle in the triangle on the right is angle M. So since A is the first letter in the first triangle, M has to be the first letter in the second triangle. What's the second letter? Well, we start with angle B. That's the angle with 2 marks in it. So the second letter in the second triangle is going to be angle Q. And then angle C is the angle with 1 mark in it. So its matching angle in the other triangle is going to be R. This is a congruence statement. It's how we tell what parts are congruent to each other. Now, the reason we like to do this with a congruent statement is because if we do it right, we don't even need the picture. Here, I'm telling you triangle LRD is congruent to triangle ZKG. There's no picture here, but we can still tell what parts match. For example, if I ask you what angle is congruent to angle L, well, L is the first letter in the first triangle. It's got to be congruent to the first letter in the second triangle, which is going to be angle Z. Which angle is congruent to angle R? Well, R is the middle letter in the first triangle. It's got to be congruent to the middle letter in the second triangle. So angle R is congruent to angle K. And likewise, angle D is the third letter in the first triangle. It should be congruent to the third letter in the second triangle. It should be congruent to angle G. And it's not just angles. We can do the same thing with the sides. Side LR, well, that's the first letter, second letter. It's got to be congruent to first letter, second letter in the second triangle. So segment LR is got to be congruent to segment ZK. And segment RD, second letter, third letter, has to be congruent to segment KG. And segment LD, that's first letter, third letter, has to match with segment ZG. So we use this naming system to save us some time. Like we don't have to draw the pictures. And the naming system works something like this. If the whole triangles are the same, that's what the congruence statement says, then the parts in the same place are the same as well. If the whole thing's the same, then the parts in the same place are the same. If the whole triangles are the same, then the parts in the same places are the same too. Now, this is a big, ugly, clumsy sentence, and it's not very precise, so we're going to change some of this. Instead of saying they are the same, we're going to change that to they're congruent. And down here as well, the parts in the same places are congruent. And we also had a new word for the parts in the same places. We called that corresponding parts. So if the whole triangles are congruent, then the corresponding parts are congruent. The sentence is still a little bit clumsy. When we write this in math, we typically write it a different way. But essentially, it's still saying that if the whole thing's the same, the parts are the same. And the way we would say that is the corresponding parts of congruent triangles are congruent. In other words, if the whole thing's the same, then the parts in the same place are the same. Nobody likes writing out this long sentence, so we abbreviate this to just CPCTC. That's going to come up a whole bunch in the near future, but hopefully we'll help you remember that. If you don't understand the idea behind it, let's try a different analogy and talk briefly about cars. Let's say this is your car, the 1974 AMC Gremlin, the worst car ever made, known for just falling apart all the time, but perfect for a high school student. So let's say you're all proud of your new car and take care of it and everything, and someone comes along and dings it, and you got to replace this front quarter panel on the car. Now, most people would take it to a shop, but let's say you are the person in your family who likes to fix everything yourself. Every family's got that guy or girl. And in order to fix like a body damage on a car by yourself, what you do is you go to a junkyard. There's one on North Avenue. And you look for a car, and you just take whatever parts you want, and you bring them up to the register, and they charge you for them. It's pretty cheap, and you can use it to fix yourself. So if you went to the junkyard to fix this car, which of these other cars would you be looking for in the junkyard? Which one of these cars would have the correct replacement parts? And I know it's funny, everybody says the big wheel, but you know that you're looking for a matching car. You want the whole car to be the same so that the parts match. Same idea for CPCTC. If the whole thing's the same, then the parts will be the same. And I put this in, assume you want your car to look like this, not to look like this, so you want matching parts. So you know you want to find the matching car. My friend Carrie has this awesome car, the Bugatti Veyron, one of the world's fastest cars in the world, and I was so jealous, and I told her all the time that she decided for my birthday she bought me the exact same car. Now, since the whole cars are the same, I can sneak over to her place and steal parts from her car to use in mine. Like if my headlight goes out, I can steal her headlight and put it into my car. Since the whole car is the same, the parts in the same place are the same. Yeah, it does have to be in the same place. I can't steal her rear view mirror and use it as my wheel, but I can steal her wheel and use it as my wheel. If the whole thing's the same, then all of the parts are the same. Well, this is CPCTC, and it works in triangles as well. So here are two triangles. If I tell you the whole triangle is the same, then we know automatically by CPCTC that all the parts in this triangle match all the parts in this triangle. That's what CPCTC says. CPCTC shows up in proofs. That's where you'll have to know this. And we're going to do a really ridiculously simple proof here and say, here are two triangles. And we're told our given information is that the triangle on the left, ABC, is congruent to the triangle on the right, triangle SRQ. And we want to prove that angle C and angle Q are given. Well, our proofs aren't really that hard. Just like any other proof, we start with our given information. So the first statement in this proof would be, hey, the triangle on the left is congruent to the triangle on the right. Triangle ABC is congruent to triangle SRQ. How do we know that? It was given to us. As soon as we say the triangles are congruent, CPCTC says all the parts match as well. And so we just got to find our matching parts. And if you look here, angle C and angle Q, they're in the same spots of the names, so they have to be congruent. So now I can say what I was trying to prove, angle C is congruent to angle Q, and the reason is CPCTC.